So, pleasant day, dear doctors, dear medical students, and welcome to our biochemistry bootcamp. In understanding better glycogen metabolism, we will take up the glycogen storage diseases. So, these are the common, not all, but the common glycogen storage diseases. So it begins with the type of the glycogen storage disease being referred to by Roman numerals. Then they have a common name, which is usually an eponym or named after a famous person. Then you have the enzyme that is deficient. And lastly, you have the structural as well as the clinical consequences. This is what I would consider as the manifestations of that particular disease. Now, I want everyone to remember von Gierke is glycogen storage disease type 1. I want you to pronounce it as von Gierke. You know why I want you to pronounce it as von Gierke? Because the first glycogen storage disease is like the first boyfriend. And what is the first boyfriend? He is a jerk. Okay? See, von Gierke. Now, the enzyme deficient, take note, is glucose 6 phosphatase. The usual manifestation of von Gierke's, the key manifestation, is lactic acidemia, and they also present with elevated lipids. Pompe, let's pronounce this as Pompe, has a deficiency in alpha glucosidase. There is a deficiency in alpha glucosidase. Tarui disease, that's glycogen storage disease type 3, has a deficiency in the debranching enzyme. Type 4 is Anderson's disease that has a deficiency in the branching enzyme. Now, I want to ask a simple question. Which of these two enzymes, debranching versus branching, where would you encounter the branching enzyme? Do you encounter it in glycogenesis, or do you encounter it in glycogenolysis? You encounter the branching enzyme in glycogenesis. What about the debranching enzyme? Where do you encounter the debranching enzyme? You encounter the debranching enzyme in glycogenolysis, which is known as the breakdown of glycogen. Now, McArdle's, the deficiency in McArdle's is the muscle phosphorylase. Hers disease, which is type 6, is liver phosphorylase. So please remember this. Now, tip. Von Gierke's disease has what we call the cherub-like facies. The doll-like or cherub-like facies. Very prominent cheekbones and tissues in the cheek area. So please remember this. Then we have Pompe's disease. Pompe's disease, there are two types of Pompe's disease. We have the infantile or the early onset. They usually manifest before the first year of life. The second type is the late onset Pompe's disease. This usually occurs after the first year of life. So the cutoff here is the first year of life. If it occurs before the first birthday, that is infantile onset. If it occurs after the first birthday, then that is late onset. Now, they present with a unique distribution of muscle weakness. It's usually in the limbs and the girdle. So hips, shoulders, upper arms, and please take note, respiratory paralysis can occur. Very unique is an enlarged heart and an enlarged tongue. Now, what do you think is the closest differential for an infant born with a large tongue or a macroglossia? First disease that should pop into your head is congenital hypothyroidism, which we also call cretinism. It presents with macroglossia. They are also lethargic, sluggish, okay? And another disease can also present with macroglossia. What is that disease that presents with macroglossia? They can present with abdominal defects like an omphalocele or an umbilical hernia. This disease is known as Beckwith-Wiedemann syndrome, commonly known as BWS. Now, can anyone think of what are the possible cancers, okay, which are associated with Beckwith-Wiedemann? There are cancers associated. There are two cancers associated with Beckwith-Wiedemann syndrome. These two cancers are, number one, Wilms tumor, which is also known as nephroblastoma. It's the most common kidney tumor in pediatrics. Then you have hepatoblastoma, which is the most common liver cancer in children. So that is Beckwith-Wiedemann. So this is your mnemonics. What do you see here in the right? What is this? This is a heart that is pumping, because Pompe's disease, okay, is the beating heart. Pompe disease is the pump because it presents with cardiomegaly, it presents with heart failure. And just to remember the glycogen storage disease type, which is type 2, just remember this. You have two hearts, okay? Take note, two hearts pumping as one, okay? Two hearts pumping as one. Now, Anderson's disease is type 4. The problem in Anderson's disease is the branching enzyme. McArdle's disease, the problem here is muscle phosphorylase. Her's disease, this is hepatic phosphorylase. So take note, McArdle, muscle phosphorylase. Her's, this is hepatic phosphorylase. Muscle, then the liver, okay? Now, if the exam is just a few minutes from now, I will leave you with the things you need to know. We have type 7, glycogen storage disease, which is Tarui's disease. The enzyme is PFK, or phosphofructokinase. We commonly call this as PFK. Then we have type 8, which is phosphorylase kinase. Okay, phosphorylase kinase. So Tarui, type 7, phosphofructokinase. Type 8, that's phosphorylase kinase. Now question, which of these two would present with hemolytic anemia. There's only one glycogen storage disease that presents with significant hemolytic anemia, and that is Tarui. Okay, Tarui's disease will present with hemolytic anemia. So let us wind up with these visual reminders. If you know your ABCs, you should know your 1, 2, 3s. So A, B, C, D. Anderson's is a deficiency in the branching enzyme. Corey's disease is a deficiency in the debranching enzyme. So don't forget this visual mnemonics. What is the mnemonics for the branching and the debranching? What's the mnemonics? It is A, B, C, D. Again, the mnemonics for the branching and the debranching enzymes is ABCD, which stands for Anderson's is branching, Corey's is debranching. Now, what do you see here at the bottom? I am introducing you to my friend known as the muscle man. What can you visually see? What catches your attention? What two letters catch your attention right now? And what did I encircle? It is the MM. So please take note that McArdle's disease is a deficiency of muscle phosphorylase. So again, McArdle's disease, muscle phosphorylase, we have my friend, the muscle man. And what glycogen storage disease presents with poor exercise tolerance and hemolytic anemia? What letter did I highlight here? It's a big letter T. So this is Tarui's disease. Okay. Tarui has anemia. Tarui, agree. There is anemia. Okay. And what letter do you see here? What letter do you see? You see an H. Everyone, give me an H. Give me another H. Give me another H. And give me another H. So everyone, together, let us say HEP. What is next? HEP. HEP. What's next? What is next? HEP. HEP. Her. Her. Hooray. Why? Hepatic phosphorylase is HER's disease. Okay. Hep, hep. Hooray. HER's is hepatic phosphorylase. Okay. So lastly, there is this very busy slide. Okay. Lifted from the Bible of biochemistry, which is Harper's Clinical Biochemistry. I just want to highlight von Gierke. That is actually type 1A. Know the enzyme. It's glucose 6-phosphatase. Next is pump. What is pump? Pump, pump, pump. That is type 2. 2 hearts beating as one. It is associated with heart failure or pump failure. Corey's disease is also known as limit dextrinosis or Forbes-Corey disease. The problem here is the debranching enzyme. So why do they call it limit dextrinosis? Because there is an accumulation of a polysaccharide known as limit dextrin. That's type 3A. Type 3B is also known as limit dextrinosis. Type 4, okay, which is Anderson's. This is also known as amylopectinosis. Type 4, that is the branching enzyme. McArdle's, which is also known as myophosphorylase deficiency. This is the one that has a deficiency in muscle phosphorylase. Then Her's disease, hepatic liver phosphorylase. Tarui, letter T, Tarui, this has the hemolytic anemia. Enzyme deficient is phosphofructokinase. Why is there hemolytic anemia? Because it is the RBC, or erythrocyte phosphofructokinase. And of course, winding down, we have type 8, okay, that's liver phosphorylase kinase. We have type 10, and we have type 9. Okay, so this ends our quick session. Happy studying, everyone, and God bless.